Okay, well, good evening, everyone. Thank you all for being here today. Really excited for tonight's session. So today we're diving into the story of Palantir, arguably one of the most powerful and fascinating technology companies in the world. As of this afternoon, when I checked, Palantir's market cap is hovering around 275 billion. Since going public in September 2020, my husband actually reminded me this morning. Palantir's stock has actually returned more than 1,200% to shareholders. So Palantir builds software platforms that help organizations integrate data, decision-making, and operations at scale. Palantir works across both government and commercial sectors. And to me, the company is especially interesting because it really marks a turning point in terms of how Silicon Valley collaborates with the Pentagon. It's one of the leading Silicon Valley firms to really seriously challenge the traditional defense primes. How many of you have heard of Palantir's Titan product? Cool. Okay. Yes. So for those of you who don't know, it's a mobile battlefield intelligence system, basically a high-tech vehicle and trailer that gathers and processes deep sensing data in real time. The Army recently ranked it among its top-performing programs in a report to Congress. And probably what's even more remarkable is that Palantir actually won the contract, I think it was a little over 175 million, to develop 10 Titan prototypes and actually beat out RTX, formerly known as Raytheon, in that bid. So really this wasn't just another contract win, but it marked the first time that a software company took lead on a major battlefield system. So we're lucky to be joined here tonight by Aki Jain, President and CTO of Palantir USG. Aki joined the company in 2005 as a software engineer, helped build the Gotham platform and...
Out of Stanford? I did, I graduated from Stanford.
Oh, we can't forget that, can't forget. Yeah, can't forget that fact. But Aki's also led just like deployment of Palantir's products across the U.S. defense and intelligence agencies, as well as key international partners. So Aki will be interviewed tonight by two of our co-hosts for the series. So Steve Bowsher, CEO of In-Q-Tel. In-Q-Tel is an early investor in Palantir. What year did you guys invest?
2006.
2006, so very, very early on.
You guys invested the week before I started technically. Might have been in August 2005.
Could be 2005.
Very early, very early.
We'll go to the nut house to celebrate.
Yeah.
I do remember that. So that must have been 2005.
Yeah. And then also Joe Felter, Executive Director of Stanford's Gordian Knot Center. He was also an early user of Palantir, perhaps arguably the first, I think the first. First real user. But with that, let's get started. So over to you, Steve and Joe.
Awesome. Well, thanks, Ernestine. I'll kick it off, and thanks for the introduction. But maybe Aki, you could give us a little more detail on your background. How did a little more about yourself? How did you come to Palantir, and how did you come on board?
Yeah, so I graduated from Stanford in 2003, computer science, and in doing computer science here at Stanford, one of the best things I did was, if you guys, BASES is still a thing, the Business Association for Stanford Engineering Students.
God,
Is it?
I think it is.
BASES a thing?
Is it a thing?
Yeah,
Current students,
of.
okay.
Anyway,
It's
well,
a
there
thing.
you go. So I was in BASES and got a chance to spend a lot of time with different speakers. And so one of the speakers I had heard speak at Stanford at the time was Peter Thiel. And so had gotten to know a little bit about some of Peter's ideas, and some I agreed with, some I didn't. But the beauty of a lot of his talks is they made you think, right? And you could have earnest debate and discussion. And so when Bob McGrew and I met, this is 2005, and he had just stopped out of his computational game theory PhD to join Palantir, and he kind of explained what they were trying to do, kind of what Peter's focus was Dr. Karp was focused on. I said, hey, I got to go do that. And I was fortunate enough that they let me write some code. So that's really how I got involved with Palantir. It was through the Stanford network and through really taking a look at kind of the combination of a company that wanted to think differently about problems, in this case defense and intelligence, but kind of embrace the complexity of those things. How can you have security, right, national security, but also have privacy, right? And those are some of the core concepts that I found most interesting when I originally heard about the company. But it's really through the Stanford network that I got involved with Palantir.
You were classmates with Joe also, right? Was that?
I was. He was. I think I was his RCC.
Okay.
So in Toyon, I think I was his RCC, and I'd met Joe, and I hadn't met Stefan beforehand, but met Joe here at Stanford prior, and I remember walking in to interview with Dr. Karp and seeing Joe, and he's like, "What are you doing here?" And I'm like, "What are you doing here?" At which point he told me he's one of the co-founders. So, yeah.
Well, what an exciting time. I mean, can you go into more detail, like the vision for Palantir when you got
Yeah.
started? I mean, you were there early days and built this company. What was the vision?
Yeah.
And I'll got some more follow-ons for that. So.
Yeah, absolutely. So I think the original vision from the founders, Peter, Alex, Joe, Stefan, and Nathan Gettings, they'd all kind of read the 9/11 Commission reports, and the fundamental observation coming out of the reports was that kind of all the pieces of information existed in different silos and security schemes and organizations, but the ability, again, to safely, while protecting privacy and civil liberties, actually following through on title authorities for each of those organizations, and the ability to effectively share those dots to create kind of a big picture of what was going on to kind of get ahead of it. There was a question kind of coming out of the report, well, is this a technology problem or a policy problem, right? And as technologists who had worked on this problem at PayPal, the vision was, or the intent of the company was to say, look, this is not a technology problem. Technology can actually be privacy protective. Technology can actually enable you to take massive amounts of data, enable the computer to do what it's great at, which is sift and sort through that data, and enable humans with intuition to actually apply their intuition to that data and kind of bring that together into a capability that enable people to answer questions more effectively. But moreover, not just when they ask those questions, but over time as new data comes in, as new insights come in, as new people come in to collaborate, how do you enable that full ecosystem of kind of questioning the data to basically get after answers and kind of watching those answers evolve over time? And so those are kind of the core principles or pillars behind the company, right? So everything has to be secure and safe and privacy labeled. You have to actually have really excellent experiences for users that are often not technical to interact with that data. How many people here have ever used SAS or MATLAB? MATLAB, yeah. Did you enjoy that experience?
No.
No. And how many of you have used some kind of generative AI? I assume everybody in the room has used some form of generative AI. Did you enjoy that experience? Yeah, probably more than MATLAB. Maybe use generative AI to write MATLAB code. We were really going after something that was a lot more like where generative AI has actually taken things, which is a more delightful experience that was going to enable people to actually spend time asking novel questions. And then from there, it had to be accurate, right? The concept was that, hey, if this software is going to work and it's going to be accurate, or it's going to work and it's going to be really powerful, it's got to be accurate. You've got to give people precision around their answers. And so that took a lot of investment in ensuring completeness to questions when people ask them, in some of the contexts that Steve most worked in and organizations that they're affiliated with most worked in, you couldn't not return one result in a query. You needed to have the completeness and the accuracy behind the data that you were sharing. So
I could know a lot of great companies don't ever get off the ground because of a funding challenge. And we're fortunate to have Steve Bowsher, who's In-Q-Tel played a key role early days.
Absolutely.
Maybe I'll turn it over to Steve to ask some questions.
Sure, thanks, and I'll ask two, maybe we'll throw it back over. Aki, I gave a little speech last week where I sort of said the founding of Palantir and SpaceX and the way they were built was sort of marked in my mind the 1.0 defense tech world, right? Because you were really the only two companies in that decade that were sort of selling to Defense Department or the U.S. government as their primary, if not only, customer. Tell me how you and the founding team sort of got comfortable with pushing through against that with all the naysayers out there that were like, great tech, great team, why are you going after this terrible market? Why not go after some other better market than that?
yes, I think only In-Q-Tel got us. I think everybody else.
We were the first non-Peter Thiel check, I believe.
Yeah. Well, to be fair, other than Peter, some of Peter's funds and private individuals that saw the vision, right? It was really only In-Q-Tel. Albeit like every other VC turned us down. Right, I think Dr. Karp has some colorful analogies that he likes to share about his hopes and aspirations vis-a-vis that rejection. But yeah, nobody really believed. And actually, even In-Q-Tel at the time, I remember both In-Q-Tel and remember Ken Short from The Quick would always say, he's like, you got to have a plan for the commercial business because you're never gonna be able to rely on the government. Like, this place is nuts, it's chaotic. You're never gonna be able to scale in the government at the rate that I think your technology could scale. So have a plan on the commercial side. In fact, the federal government never really wants to be even more than 10, 15% of your business as a commercial technology company. And I think the way that we really persevered through it was really a massive credit to the founders. They had a very clear vision. They came together, right? There's a lot of different things that they could have been doing or spending their time, energy, and money on, but they came together. They had a very long-term vision. It wasn't a, hey, let's deliver results. If you don't have $100 million in revenue by year 2, which a lot of other companies did. You have to keep in mind we were growing up during the Web 2.0 era, so we were Defense Tech 1.0, but it was Web 2.0 was kind of the thing that was happening. And if you don't have a really quick, consumer-driven network effect capability, and you're not driving 100 million ARR by year 2, you're not interesting. What was really interesting about us, and why I'm thankful those VCs turned us down, was that we had long-term investors that saw the bigger picture. They knew that in order to preserve the national security of the country, you needed deep investment, you needed deep technology. But moreover, these were markets that there was no DI/UX, right. There was no really, In-Q-Tel was kind of the only game in town that was trying to take technology from Silicon Valley and bring it to the government. And even then, a lot of In-Q-Tel would often get intermediated by the primes, right? Or the integrators who would kind of take that tech and say, just give us shrink wrap and we'll take it from there. And so fundamentally for us, it was the founders' vision saying, look, we have to solve this problem. We're very fortunate they had deep pockets and the ability to invest and kind of see it through kind of a very long time till we were starting to generate real revenue. I think we were probably 5 years till we're really generating real revenue. And then this kind of commitment from an incredible set of hobbits who were really focused on serving the defense mission and the intel mission and really believed in the work we were doing. Again, you just have to think about it. It's like all your friends are doing consumer startups. Literally, all of our friends were doing consumer startups of some kind. There were very few kind of B2B startups even at the time. And we were focused on this thing almost singularly. And most of the time people thought we were, some kind of front for the CIA or something like that, right? They didn't quite actually understand
a lot of conspiracy theories.
There are a lot of conspiracy theories. And so it was the perseverance of great folks that were really dedicated to it, great investors and founders who had a vision and were pushing on it. And then frankly, the technology really matured. Again, it was at a time when a lot of the things that were behind the kind of green door at Google, things like Hadoop even, right? Lucene, some of the core libraries that enabled companies to move faster from the open source started to emerge as a function of those papers coming out and enabled the technology to move a lot faster than it would have otherwise.
So to me, the really interesting thing that Palantir did in the early days that was totally new and different to any sort of CIA employee and other end user in the government was this process of product discovery that you guys did, where you guys would fly out every 2 weeks, I think it was back then, and you meet with end users, you'd show them some sort of mock-up or prototype, you get their reaction to it, then you go back and you code for 2 weeks, based on their feedback, then you come back in another 2 weeks. And this sort of, product discovery, lean product development, everything you guys learned from Steve Blank and others and some of these other classes, that effort, and it had been done in Silicon Valley before, but never applied to government before. Yeah. That was the thing that blew the government users' minds when we talked to them, was like, these guys want to actually sit down and understand how I do my job on a day-to-day basis, and listen to my feedback, I'm seeing my feedback incorporated into the product in 2 weeks. Like, that's never happened before. Yeah. Maybe share with the audience a little bit about that process.
Sure, absolutely. Yeah, I think Stefan's nickname for a long time was 2 Week. Yeah. Every time we'd go there. And he really loved the JetBlue red eyes. It was not great. So a lot of this was ultimately thinking about kind of user-centric design, right? And the biggest takeaway for us was that ultimately, again, this is kind of trivial at this point, or trivialized at this point. It's like, don't kind of listen to folks when they say, hey, build me X, ask them what their problem is, what is the problem they're trying to solve, and then work backwards from there towards the thing that you actually need to build. And so our methodology really, which emerged over time, is, start with the problem, find the users who are trying to answer the problem, observe and watch them actually log into 7 different systems to try to answer the question to that, answer the question that they're trying to solve or the problem that they're trying to solve, and then work within each of those systems almost fractally to get after the data, right? Because if you just keep doing that in an iterative cycle and kind of popping the stack on it, what you end up doing over time is kind of by solving problems, you're mapping the data in the organization into some kind of semantic meaning, what we call an ontology. And that's what becomes the most valuable thing for that organization in working with Palantir. So, and we've been doing this really since the origin. Most companies they come in, a consulting firm pitches you like a 5-year plan to take all of the data in your organization and map it into the perfect ontology and modernize your technology stack over that 5-year period. And in reality, by the time you get to year, like month 5, let alone year 1, the whole thing's already out of date, right? And they're just kind of selling kind of a services or a human-based kind of hourly consumption model. And so what we really were observing was, well, if I can solve a problem for you today and create you as effectively a sticky user who's going to be bought into kind of driving iteration and ideation on the product capabilities, we were going to end up with something that actually worked, that people wanted to use, and more of they felt some kind of agency or ownership over that outcome. Where that's evolved to today, which is really interesting with Foundry versus Gotham, our original kind of product stack, is that we've now made that very much self-serve. So with generative AI, with the advent of new technologies that enable them to effectively drive developing capabilities on top of the data substrate or the ontology, literally they can do that 100 times a day, should they want to, without needing one of our people or needing some other technical expert in their domain. They can effectively do it in the platform, leveraging self-serve and really driving a developer ecosystem. But we're starting with the ontology. They're starting from something. So they're starting with some kind of hive mind or understanding of their organization that they can then add on to and kind of collaboratively work to kind of increase. So in some ways, the original analogies with Wikipedia, if you remember, everyone would say, well, I just need Wikipedia, right? And it's like, well, that will only get you so far, right? Once you want to do more structured things on top of the data. In some ways, that's really where we've gotten to, but now, given that ontology that the organization has created, they can very quickly kind of skip the first 80% of the DevSecOps stack and just kind of like get after delivering capability.
Yeah, I forgot about the Wikipedia.
Yeah, remember that was the most popular analogy.
That was the popular analogy.
We just need Wikipedia.
Yeah, Aki, so just doubling down a little bit of something Steve said about just the speed and urgency that Palantir worked at. I remember when I was running a combating terrorism center at West Point, which we're lucky to have Colonel Sean Moreau here as the current director of that terrorism center. But a group from Palantir came up. This is back right when you joined.
Yeah, Jason and the team.
Yeah. And I didn't know who they were, but I just got out of a Stanford PhD program. I heard they were CS majors out of Stanford, so I loved them right off the bat. But I was talking about my problem. They said, they said, can we look at the data? In this case, we had a bunch of data on foreign fighters who had come into Iraq from Sinjar papers, big massive records, and we had tried to make some sense of it. But literally, while I'm talking to them, Jason team, they just started doing their magic, and like by the end of our conversation, they're developing, coming up with findings that we had missed using kind of Stata and regular off-the-shelf statistic programs. So it's just clear the value proposition, and I was a true believer after that. I remember years later, literally in Afghanistan, bringing a Palantir group over, and then Mike Flynn, who you may have heard his name, but at the time he was a very well-respected Intel chief for General McChrystal, and same situation. We gave him some data, and literally sitting there with Mike Flynn, General Flynn, coming with answers that were relevant and actionable in real time, right there, understanding the nature of the threat. And so it's so obvious how much better Palantir was than anything out there. Certainly, things like D6. Long way of saying, why was it so hard to get adopted? What were the biggest challenges and how'd you overcome it? It's like David and Goliath. It's like, it seemed like a no-brainer to those of us in the soft community. Others like, Palantir's way better and it's actually cheaper and we need it because people are dying on the battlefield. What were the biggest problems you had and how did you overcome them?
Yeah, it's good. So it's one of the things early on is we refused, so when you have no experience, you don't value experience. So we refused to hire anybody with experience, right? And at least in the domain, right? So we weren't hiring 4-star generals who could help us navigate, or even 2-stars or 1-stars, right? I mean, Doug Philippum was our first, service member who joined the company. And just to be clear, Doug applied 3 times, and it was only because if anybody's met Doug Philippum or watch him online, through his sheer force of will, and one of our developers, he grew up in Arizona together. And he vouched for him. That's why we hired Doug, right? Because we're always so worried about, we really treasured and valued the outsider perspective, right? We didn't want to be insiders, and we didn't want to kind of approach it as insiders. We wanted to approach it like with outside view and kind of say, hey, we're going to just we're technologists. We're not subject matter experts. We don't understand how you do what we do. None of us have been in combat in the ways that you guys have. And so we really kind of held that for a very long time. And because of that, I think one of the things that we really probably underappreciated, was the importance of just how deep relationships go in DC and how deep and long some of those programs are planned for. And frankly, just, you hear about it, kind of the revolving door, all these things, which I'm a fan of industry going to government and government coming to industry. I think that actually increases the understanding of what happens on each side of the fence. But a little bit, you had a little bit of that military industrial complex that was unwilling to kind of rock the boat, right, to do things differently. And here we were kind of, bright-eyed Silicon Valley people saying, but it works, it's substantive, like of course you want it, right? And we just hit every single possible, speed bump / wall that you could imagine, on the way. And DSIGs was one of them, but it was probably the most public. So DSIGs was an Army program. I think Raytheon was the prime, right? I think Raytheon was the prime, and it wasn't delivering. We were sending Jason Payne, who worked with Joe at CITSO and other places. He was out in Afghanistan sitting with, soft warriors, sitting with conventional forces, and people were dying, right? And they didn't have the tech they needed, and they were being handed a thing that sat in the corner and told to use it. And you just have to remember, broadly, it's a lot of credit to the soft community, but also conventional forces. These are the same folks that were literally going to Sports Basement or the equivalent and buying handheld Garmin GPS when they deployed, because they weren't actually getting the resources and things they needed to be as safe as possible as they possibly could when they were out and about. And so it was luckily actually through the Counter ID task force, right, that we really got involved directly and were able to drive kind of a groundswell from commanders and operators in the field to kind of overcome some of the very high wall that you had to overcome in order to get involved in the community. And frankly, a lot of that was In-Q-Tel on the Intel side, but actually In-Q-Tel was how we got involved with JIADF and some of the other organizations that adopted us. And so it's a long way of saying the reason it was so hard was, one, culturally we didn't fit, right? And we hadn't quite broken through to understand how to modulate our approach. Two, contractually we didn't fit. We were selling a commercial item. Most contracts in the government are done as a function of time materials or some kind of cost basis, right? So it's like I have a person, I pay him $100,000 a year, I'm going to put a 10% markup on that, which is I think like the federal limits, like 10 or 12% for profit. And then that's it. You know exactly what the person costs because you can see what it's cost counting, what I paid them and how much profit I took. But then I have this thing called overhead and G&A in there, which is typically doubling the price. So now this $100,000 person's a $250,000 person to the government, where they had a lot of different things. And so the incentive structure for those companies was just to sell more bodies, right? It wasn't, I'm going to build a product, I'm going to spend my own money, and if it's useful, the market will bear, paying what it's worth, and then like market dynamics will work through. So we were out there talking commercial when everybody was like, why would I buy a commercial capability? I have a really, really hard defense problem, right? So we're too far ahead on that. And then the third thing I think ultimately was early on, it was just really hard to know. All these problems are classified, right? It's, you go to a meeting, you meet with some people, you think their name is Jim and Jane, and then somebody comes in and calls them Brian and Samantha, and you're like, it's very strange. None of us had clearances, probably for a couple of years. It took us a couple of years before we even built a facility, got a facilities clearance. So just all these different walls where you kind of don't know what you're doing. You're a little bit delivering, but feeling in the dark. Again, there weren't accelerators like DIU to help us work through this. And we had Steve and the team, at In-Q-Tel and then at the Quick that were really, it was a team of 10 people maybe, right? That was fighting to get commercial capability adopted against, a 1 million person army. And that's why I think it took so long to really get through there. There was no way to quickly kind of accelerate into these capabilities till much later.
Wow.
Yeah.
Okay, so let's fast forward a little bit. Mm-hmm. So if the aught decade, if that's the name of it.
Which one's the aught? The tens or the
zeros? Yeah,
zeros,
0
okay.
to 10.
Okay.
At least that's my theory. If that was SpaceX and Palantir, mm-hmm. right? And can't tell you the number of calls I got from venture capitalists who looked at Palantir and said, "Great team, great tech. I don't understand the market, Steve. I try and explain them the market, and they would not be convinced because apparently I sucked at it. Explain the market to them, and they would not invest, right? Yeah. Fast forward to 2016. Yeah. When Palantir and SpaceX are now 2 of the 5 most valuable private companies in the world, right? Mm-hmm. Exactly the types of companies that make the venture capital market work. And venture capitalists are like, oh my gosh, we blew it. We missed on this opportunity, and a little bit of herd thinking, right? They all jump in, in 2016 into investing in other defense tech companies. By that point, you guys are well on your way, and you actually pivot, or not pivot, but you expand to the commercial. Tell us about that decision. Maybe it happened a little bit earlier than 2016, but that's about when you got to critical mass, I think, in the commercial.
Yeah, I think it, if you go all the way back to the great financial crisis, right, and a little bit of the fallout from that with the subprime kind of lending crisis, we were doing things in and around commercial with Metropolis, which was our finance platform. So we had a government platform, Gotham, and a finance platform internally called Hedgehog, externally called Metropolis. And basically we were always dabbling in commercial, but the heart and soul of the company was very much in government. And I would say it's probably like around 2012, maybe 2013, 14, where we really started to pivot hard on what is now Foundry. Right. And Foundry grew out of the work we'd done in finance, a lot of it with Bridgewater, with JP Morgan, with a couple of very large financial institutions, and then the experiences we had with Gotham. Again, we had started building Gotham in 2004, 2005. And the tech stack had just evolved a ton. Compute and cloud computing was just massively kind of proliferated. I mean, obviously much more so now, but at the time it was a big innovation. And so all of a sudden, the way we could design systems and think about systems and really do distributed computing successfully and repeatably had changed, right? I wasn't now building software to run in somebody else's data center. I could actually run in the cloud in a consistent environment, at least in Amazon. And so really the pivot towards commercial was a function of recognizing, one, large organizations often perform very similarly. So a large government organization is very similar to a large commercial organization. Now, one has a profit motive, one has a mission motive, and so there are different ways by which they do accountability, they do different types of things. But what was really interesting was really large banks functioned very similarly to really large government institutions. That was kind of the first thing. The second thing was, and Stefan kind of came up with this concept, it's like reframe the data to reframe the operations, right? And so there was a recognition that ultimately it all came back to the data, right? So when we were popping the stack and we were going down trying to get at the data and kind of fractally kind of like get lower and lower and deeper into the data to map it out and build the ontology, what we were really doing was reframing the operations of an organization and trying to figure out how does that work, really try to remap how that organization can leverage technology to make better decisions. And this is the same problem in the commercial space. And then third was security is as important in the private sector, if not more, if you're a regulated institution like a bank, than in some ways on the most classified networks where you can make a lot of exceptions to get the mission done if you need to, right? And so, whereas you can definitely not do that in a bank, right? Like it's highly, highly regulated. And so with those kind of core principles being the same between the two industries and then kind of where the finance product kind of had gone, we started to build Foundry, right? And what Foundry really is the agility engine. It's cloud first that enables you to take all the silos in your organization. Instead of n-squared problems where you're trying to map them all to each other and make them all work, you kind of map them to Foundry as that agility core upon which then you can do your work. And that's where the ontology lives. And so with commercial, that pivot was one, government was doing well, but we recognized that there was massive opportunity in the commercial side given the core technology we'd built, the deep tech. And then two, because the problems were so similar, it was something where it wasn't going to be a huge leap to adapt it into those capabilities. And Foundry really drove commercial first. In fact, we only brought Foundry heavily into the government, probably in like closer to 2017, really 16, 17, as kind of Army Vantage was taking off with General Milley. And so before that, it was primarily in commercial. So 12 to 16 was a big building phase for Foundry, commercial focus, a lot of similar problems, but kind of replatforming cloud first. And then kind of really 16 into 17, Foundry then came back to the government and kind of took off. Yeah. And we kind of find that one of the coolest things about our company, because we're literally about half revenue-wise commercial, half revenue-wise global government, is that we learn things on the commercial side that really massively increase the pace of what we're able to deliver for the government. Apollo and the way we deliver software being one of those examples. And then on the government side, there are certain foundational things like security, like privacy and civil liberties, like audit, like regulatory frameworks, and the ontology that have really massively benefited our commercial business. So it's kind of a unique thing about us because we're truly 50-50, really right in the middle in terms of revenue, which there aren't really that many companies that are formed that way.
At 50-50, very few.
No.
Let me ask one more question, I'll throw it back to Joe. So the engine for all this is the forward deployed engineer.
Yeah.
Talk about that.
Yeah.
We had one gentleman attend here last year, Jake Birdwell, that ended up joining you guys in part. So some of the students here may end up interviewing to be one. So talk a little bit about how you created that role, because you were the company that created that role, what that role does, and how that's different from sort of the way software is normally sold.
It's too bad Sham didn't trademark it when he came up with the name.
Well, there's the forward deployed capital, right? There's someone who started a venture firm.
Mark Sanda did, forward deployed VC, FDVC. So the forward deployed engineer, what is this really about? So if you believe, look, there are some brilliant people in Silicon Valley. They usually wear black t-shirts or black turtlenecks, not t-shirts, long sleeve. And they can sit here and they know what the future is going to be, right? They can tell you what consumers want. They can come up with incredible product ideas in a vacuum, take them from paper to product in a very quick period and make a ton of money really quickly. That is not who we are, right? So we have a core set of operating principles, values, and foundational ideas, but everything else comes from the field. And so the forward deployed engineer is the engine for innovation at Palantir. If you think about, and what that really means is we embed with our customers to understand their use cases. A big reason why we built Foundry was to make it easier for us to do things in the field, to service demand, and to ultimately find common ideas across industries that we could then build frameworks or kind of bake into the core product and kind of create a virtuous cycle. But really what we found is that most companies out here were building software, they were shrink wrapping it. You guys are probably too young, but they used to have CDs and DVDs, and software came on them in a box, and it's actually shrink wrapped. It's kind of funny. There's a license key on the side. Kind of funny, right?
I'm old enough, I remember.
Software just, but shrink wrap software, and then you throw it over the fence, and you throw it to somebody in that company, typically the IT department or the CIO that was going to implement it, or you throw it to a third-party integrator that was going to integrate it with a bunch of other software, kind of create a Frankenstein, and then give that to the customer. And what we found very quickly, we tried those models, it just didn't work. We weren't able to innovate at the pace of the mission, really, but at the pace of Silicon Valley by throwing stuff over the wall. I mean, you're on, at best, a 6-month iteration cycle. And we wanted to be on a monthly and then weekly, if not daily, iteration cycle. And so a lot of what we did was realize, look, we needed to be forward, we needed to embed with our users, and we needed to live their mission to truly understand their problems and then drive solutions that would serve those problems. And so that's kind of where Sham came up with this concept of the forward deployed engineer. And as we were building out, Bob and I were building out core product, he was building out forward deployed engineering, and I was kind of between the two, spending a lot of time in DC. And so really the forward deployed engineer is all about embedding to understand the problem space, helping drive adoption with our customers. So again, more and more, frankly, we're doing that with generative AI. We have a concept of the AI forward deployed engineer now that's really successful in a number of places. And but what we're really trying to do is glean insight into the frameworks and the product features that we need to be building into the core platform to actually drive the next level of success, or kind of to figure out where the puck is going, so to speak. And it's two ways. Sometimes we're bringing ideas and concepts forward to our customers. Sometimes they're bringing ideas and concepts to us. But the forward deployed engineer is absolutely the engine of innovation that drives what our product teams do.
I got one more follow-up question now.
Yeah.
So I was interested to hear that you launched the AI forward deployed engineer. What do you think the ratio is today of human forward deployed engineers to AI?
Not enough.
And then what do you think? Where do you think it's headed?
So yes, we just started measuring AI FTE minutes per day as a metric. We're not far enough along yet. Okay. So in our early work with a couple of more forward-leaning customers and some of our foundation lab partners, we are seeing pretty massive results. I mean, it's not just a tier 1, tier 2 kind of capability. It can really enable people to do a lot more. we've had something called AIP Assist for a long time, which helped you navigate how to do something on the
Right, yeah,
platform,
right.
but you still had to do it.
Yeah.
Now the
Nowadays,
IFTs are actually just doing it and driving a set of operations. So if you go to build.palantir.com, you can play with the platform a little bit and kind of see some of where we're going with it. But I suspect, I think the stat from OpenAI is they went from 0% to 50% of code written by AI in about a year.
Yeah.
I suspect we'll hopefully get to a similar balance pretty quickly.
So for any of the entrepreneurs out there in the audience, I think one of the really interesting areas to be digging at right now is if the future, and this is what I hear from my friends at big tech companies, if the future is towards a significant portion of your development organization is AI-based as opposed to human-based, what is the software you need to manage that and run that organization? Because it's not nothing, it's something, but they really don't have a sense of what that is yet. And so it's one of the real problems that I hear when I talk to people like, hey, what's an unsolved problem out there that you'd like to hear? It's something around that. So
yeah, no, it's the concept of ergonomics, right? It's like, if you had a human software engineer, okay, they need a chair, they need a desk, they need a computer, they need an IDE, they need code, they need Git, they need some data, they need some coffee, food, cafeteria, bathrooms, etc. Like little nap room in case they need some rest. What are the ergonomics for an AI software engineer? Right? How does that AI software engineer actually even understand your code base? I mean, a lot of code bases, the code is the documentation, right? And actually that works for AI software engineers better than you'd think. But what about the standards upon which you want it to actually write code? I think right now we're seeing a lot of humans leveraging AI for scale. Has anybody, software engineers in the room, anybody vibe coded? Or non-software engineers, has anybody vibe coded? All right, so you vibe coded. Like, I don't really know Python. Like, I was a Java, C++ Java dev. Python's my new favorite language, thanks to vibe coding, right? How quickly you can actually prototype something. But now how do you do that in a large organization with a couple of million lines of code in multiple languages? There's a build system, there are security requirements. Right now, a lot of it is human oversight of AI, but over time, you can imagine AI software engineers are going to interview for roles. There's going to be a bake-off. Maybe you hire one for a month to build a particular part of your capability. How do you divvy up that work? Are you just writing all these PRDs and MRDs to kind of drive its behavior? What are you doing? So it's ergonomics. That's absolutely an unsolved problem.
So we just have about 10 minutes, so I'll ask one more and get a little bit of time for questions. But so broad questions. You mentioned 2016 when that year. That was about the same time like Project Maven. You heard of that, and even Palantir was, there was not as popular with some of folks in Silicon Valley. I was always a huge fan, but maybe you can talk about. Let's fast forward now. What if you're looking at a group of prospects? These are our best and brightest anywhere in the country sitting here in this room, who may be interested in Palantir. How do you? What's their value proposition? Why should they work for Palantir? How would you get them fired up about Palantir of today?
Yeah. So look, I mean, first and foremost, just do something that matters for the love of God. Don't build the next TikTok, please. My one appeal to the youth of today, right? Now that I'm old. Look, do something that matters, right? Now, I think, why is Palantir, in my opinion, a great place to be? And I say as I've been there, this is year 20, right? So, look, at the end of the day, I always stayed pretty consistent. It's like, look, there are a lot of places that have an incredible business. There are a lot of places that have an incredible product, and there are a lot of places that have incredible people. It's very rare that you get all three, right? And I'll be honest, I think about a company like Google. Google is an excellent company. And let me just be clear, Google is all in on defense now. They might not have been in 2016, but they are all in on defense, right? And they're doing incredible work. It's also a massive company, right? What's really incredible at Palantir is with 3,500 people, we're extremely mission aligned. We've been 3,500 people for a while, so we're not growing at a pace that's unreasonable. We're trying to leverage technology to really drive a lot of that growth. So we're 3,500 people. You have some of the smartest people in the world that you will be able to teach something to. We're very open-minded and learn from. We have an incredible business that's only doing better and better, both on the commercial and the government side. And the tech that we get to work with and the mission impact it has, I think, is unparalleled. So what's beautiful about Palantir is, we have no ladders, right? So there is no software engineer 1, 2, 3, 4, and every year here are the check boxes to get your next promotion. We don't care. That's not really how we work. It's a decentralized, autonomous company where we want people to really ultimately express what they're great at. We don't want that you do not have to be well-rounded, right? Like, it's great you're in band, and it's great that, you know, you speak 3 languages and you can code and you can juggle and everything. We honestly don't care. We want to know, what are you great at? What are you the world's best at? How can you take that thing that you're great at and be even better and use Palantir as a platform, yes, the technology, but actually the company, to get access to problems that are going to meaningfully change the world or have some kind of impact. And look, there's danger when you actually have software that works. It could do really great things, and there's also consequences and potential for bad things to occur. So you've got to be able to grip that and work through it, and then express what you're great at on top of that platform as part of this kind of collective. That's really how we think about it. Dr. Karp has been known to call it kind of a Swiss watchmaker village, which I have never been to a Swiss watchmaker village. I don't fully understand, but what he's really trying to say is think about it as more of an artist colony and not kind of like a very kind of like you're just a cog in the wheel. And Jake's a great example of that. Jake Birdwell, who joined us and works on a bunch of different projects actually with Alex in the Office of the CEO, but it's very varied, and you're really kind of doubling down on what you're great at, again, on this substrate that gives you access to incredible opportunities way earlier than you think you're really going to be open to it. And that is really what's very special about Palantir. So yes, great people, yes, great business, yes, great technology. We do have all 3 of those, which I think is rare. But moreover, it's who you get to be, and I think this is why you see so many companies they call it the Palantir diaspora, so many companies that former Palantir alums, when they're in year 5 or 6, might go start, that are doing so well, right? Because they've been through that gauntlet, they've learned that, they've really been able to figure out what they're great at and how to apply it, and then had a lot of mission impact.
You know, very few come along that change the nature of the business, change the nature of the agencies they touch, and actually survive to become a catalyst for change for an entire other bunch of companies that follow. I mean, think about, those of you who are familiar with Tesla, the automobile industry looked the same for 100 years. It went through consolidation in the 1920s and 1930s. There wasn't a new player for literally 100 years until Elon Musk said, screw all this, you guys are all wrong. It's not about internal combustion engines. It's not about distribution channels through dealers. It's not about, you know, all this like go into a dealer and have to negotiate, et cetera. He changed the business model and technology in multiple levels. That's how you should think of Palantir. Multiple things converged. A bunch of naive people thinking they could sell software and change the government. But in fact, there were a set of technologies that emerged simultaneously with those insights about, hey, wait a minute, the government has these data problems, and we've been using tools that, you know, were 20 or 30 years old, but technology has changed. The other one was changing how government writes what are called requirements. Is, you know, no, we're going to have people sitting in a dark room who haven't been out to the field and actually try to kind of predict the future by sitting in the room. And they changed that back to not only forward deployed engineers, but basically unknowingly recapitulated what the OS R&D did during World War II when they actually had forward deployed engineers, what Bill Perry did at ESL, sitting his engineering team at NSA, understanding not only what the customer was doing, but collaborating on building those products. And then Palantir is an heir to all those get out of the building processes that we tend to rediscover almost every generation, but in fact changes the game. The other part that you should understand about Palantir was, and again, I'm going to use it not as a pejorative, but as a compliment about the naivete thinking that selling to the government was enterprise software sales. It looks, and I know I've said this in previous classes, anything people knew about selling to commercial companies was actually detrimental to understanding how to sell to the government. You talked about that learning process, but it actually was good, I think, in hindsight, because you had to learn it ab initio, from first principles, of actually getting out, getting your teeth kicked in, building a set of advocates and essentially our own insurgents inside the system to bypass this kind of, you know, almost government triangle of existing existing primes, prime contractors, Raytheon, et cetera, Lockheed, Boeing, Northrop Grumman, the existing ones, and the requirements writers and the, people in Congress who had vested interest in just keeping the status quo the same. And Palantir was a catalyst for every defense startup that followed. Palantir, SpaceX, et cetera. And it's taken 20 years, and the final culmination of these changes are going to go on in this administration, where when you have the U.S. Army Secretary to say that, yeah, we should probably get rid of at least a prime, maybe more, we're essentially flipping the entire acquisition system on its head based on the pioneering efforts of Palantir. So congratulations.